Hello everyone, this is Yumiko's channel. This time I would like to do the experiment of Buffon's needles together. First, I will explain Buffon's needles. The experiment of Buffon's needles is a famous one. To find the value of pi, it's posed by the mathematician Buffon. In the Buffon's needles experiment, when needles are thrown randomly on two parallel lines drawn at equal intervals, we count the number of needles dropped and the number of intersections with the lines, and find the average value of the intersection. We can find the value of pi by substituting it into the following formula. The average value of the intersection is m. The width of parallel line is d, and length of the needle is l. The substitution is m equal to 2l/pi d. So pi equal 2l/dm. I don't prove this, but we'll be able to believe Buffon. Let's do the experiment. In this experiment, we will throw 100 toothpicks. We have already thrown 90 toothpicks, 5 at a time, and recorded the result like this. So let's throw the remaining 10 5 at a time. Throw them on these equally spaced parallel lines. First, let's count the number of intersections. 1, 2, 3. 1, 2. 1, 2. 1, 2, 3. 1, 2, 3. The total is 13. Second, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 0. The total is 12. Let's summarize the result. It will look like this. Now let's do the calculation. The average number of intersections is m equal 2.08. The width of the parallel line is d equal 2, and the length of the needle is L equal 6.5. And we use the formula pi equal 2l/dm. The result is 3.15, which is very close. Pi equal 3.14, very close. Conversely, we can also calculate and find the length of a thrown needle by substituting it into the following formula. L equals pi md/2, What's more, the objects that are thrown don't have to be a needle. Anything that is bent, like a paper clip, or even anything whose length cannot be measured, and we can calculate their length. Let's do the experiment. In this experiment, we will throw 100 paper clips. We have already thrown 90 paper clips, 5 at a time, and recorded the result like this. So let's throw the remaining 10, 5 at a time. Throw them on these equally spaced parallel lines. First, count the number of intersections. 1, 0, 1, 1, 2, 3, 4, 1, 2. The total is 8. Second, 1, 2, 3, 4, 1, 2, 3, 0, 1, 2, 1. The total is 10. Let's summarize the result. It will look like this. Now let's do the calculation. The average number of intersections is m equal 2.94. L is the length of the paper clips, and we use the formula L equals pi dm/2. The result is 9.23. Let's measure the length of the paper clip. It's 9.1. The result is 9.23, which is very close to L equal 9.1. The result is amazing. We were able to calculate the length of the paper clips without having to measure them. In Buffon needles, even if it's not a paper clip, but something that is too hard to stretch, and you cannot measure the length, you can still find the length with this experiment. Buffon performed the Buffon needles experiment to find the value of pi. But isn't it amazing that we can do something like this? This is the end of today's experiment. Next time, I'll tell you about a movie that I watched with Yumiko last Friday. Kokuho, National Measure in English. Bye.